The calculations have now been completed, and they are nothing short of astonishing. Following yesterday's confirmation of Atlas's non-gravitational acceleration, Avi Loeb ran the numbers, and what he discovered may fundamentally change the way we view this mysterious object. According to the laws of conservation of momentum, Atlas should have lost at least 1/16 of its total mass during its close passage near our star. We are talking about billions of tons of material lost in just a single month. But here is the problem. We are not seeing the massive gas cloud that such an enormous mass loss would inevitably produce. This direct contradiction between physics and observation is leading to an unavoidable conclusion, one that is sending shockwaves throughout the scientific community. The Atacama discovery that changes everything. The breakthrough came from data obtained by the Atacama Large Millimeter Array, ALMA, one of the most advanced radio telescope networks on Earth. On October 29, 2025, ALMA detected that Atlas was 4 arcseconds offset in right ascension from where it should have been if its trajectory were governed purely by gravity. 4 arcseconds may sound tiny, but in astronomical navigation, this is enormous. This deviation strongly suggests that forces other than gravity are acting on the object. The moment Avi Loeb received these results, he immediately applied the conservation of momentum equations to calculate what such acceleration would require if Atlas were just a natural comet. The physics is simple, but the implications are extraordinary. For Atlas to accelerate to this degree by normal cometary outgassing, the nucleus would need to lose at least 1/16 of its entire mass. Based on the observed trajectory, the total evaporation timescale would be under 6 months. Since Atlas spent only about 1 month traversing the perihelion distance of 203 million kilometers, it would have needed to lose that 1/16 of its mass during that single month. The missing mass problem. This is where the mystery becomes truly baffling. Earlier measurements from the Webb telescope indicated a mass loss rate of about 150 kilograms per second, which produced no detectable non-gravitational acceleration over the 5 months prior to October 2025. From this, Loeb concluded that Atlas must have a minimum mass of roughly 33 billion tons. If Atlas did indeed lose 1/16 of that mass, then the cloud around it should contain at least 5.5 billion tons of material. A cloud of that magnitude would be unmistakable. It would be easily detected. And yet, we are not seeing it. Around Atlas right now, if the non-gravitational acceleration truly resulted from natural cometary evaporation, then the observation window in December will be absolutely critical. On December 19, 2025, Atlas will pass closest to Earth at a distance of 269 million kilometers. This moment represents the single best observational opportunity in human history to study this object. Hundreds of ground-based telescopes, along with the Hubble and Webb space telescopes, will be pointed directly at Atlas. Between November 27, 2025, and January 27, 2026. Atlas will be under continuous monitoring through an official International Asteroid Warning Network, IAWN, campaign. This will be the moment of truth. If this massive observation effort fails to detect a large gas cloud around Atlas, then cometary evaporation cannot explain its non-gravitational acceleration. As Avi Loeb states, if we do not observe a massive gas cloud around Atlas in December, then the non-gravitational acceleration reported near perihelion can be regarded as a technological signature of a propulsion system. This scenario brings a disturbing sense of déjà vu. The first interstellar object, Oumuamua, also exhibited non-gravitational acceleration, without any visible signs of gas or dust, even under deep observations by the Spitzer Space Telescope. This forced some comet experts to label Oumuamua a dark comet, meaning a comet with no visible tail. But as Loeb points out, a tail is literally the defining signature of a comet. Calling something without a tail a comet is an oxymoron. A spacecraft with an active propulsion system, however, could show non-gravitational acceleration while producing no cometary evaporation at all. As Loeb famously phrased it, it could be classified by comet experts as a dark comet, in the same way a cave dweller would classify a smartphone as a rare stone. The stakes of this December observation campaign have already drawn intense attention from science communicators, many of whom are loudly insisting that Atlas is definitely natural. However, Loeb points out a crucial principle. Scientific truth is not determined by public opinion, or by loud voices, but by data, especially when that data does not fit existing models. While communicators make sweeping claims on social media, Loeb has published 11 peer-reviewed scientific papers in recent months specifically analyzing Atlas, systematically documenting and mathematically evaluating its unprecedented anomalies. And the challenge remains for anyone claiming Atlas is natural. They must explain all 9 documented anomalies. Atlas continues to challenge everything we thought we knew about comets and interstellar objects. Let's examine the anomalies, each one more baffling than the last. First, its orbital alignment. Atlas travels along the same plane in which all the planets orbit, the ecliptic. For an object entering our solar system from interstellar space, this level of alignment is statistically astonishing. It's like firing an arrow from another continent and hitting the bullseye of a target on Earth. The precision is almost impossible by chance alone. Second, the physics-defying jet. Comets typically eject material in a direction opposite the Sun due to solar heating, an effect well understood and consistently observed. But Atlas does the opposite. Its primary jet points directly toward the Sun, defying conventional models of cometary behavior. It's as if we were watching water flow upward in a waterfall. This reversal violates established physical laws governing cometary outgassing. Third, the size and speed contradiction. Atlas's brightness suggests a relatively small object, but its velocity tells another story. Its high speed implies a much more massive body. This contradiction violates basic principles of orbital mechanics. Imagine seeing a compact car moving with the momentum of a freight truck. It just doesn't add up. Fourth, the perfect timing. Atlas arrived at the exact moment to engage in close gravitational encounters with multiple planets in succession: Earth, Venus, and Mercury. The timing is so precise that it borders on intentional. For a supposedly random interstellar object drifting through space for millions of years, this kind of sequential planetary alignment is astronomically unlikely. Fifth, the industrial metal composition. Spectroscopic analyses of Atlas reveal a composition that is unusually rich in metal, particularly nickel without iron, closely resembling industrial alloys rather than natural cometary material. It's like discovering stainless steel in a place where you'd expect only ice and dust. No known natural processes produce this composition in comets. Sixth, the extreme dryness. Atlas is the driest object ever observed in our solar system. Comets are classically described as dirty snowballs, fragments of rock and ice with water as a major component. Yet Atlas exhibits virtually no water content, even when heated by the sun. This defies the very definition of what a comet is supposed to be. Seventh, the impossible polarization signature. Light reflected off of Atlas shows a polarization pattern that does not match any known natural substance. Polarization refers to the orientation of light waves, and every known material produces a specific, predictable pattern. In Atlas's case, the data suggest an artificial optical surface, a reflective quality that simply doesn't exist in nature. Eighth, the WOW signal connection. Atlas's point of origin in the sky aligns suspiciously well with the region from which the famous WOW signal was detected in 1977, the strongest unexplained radio signal ever recorded, and long believed by some to be of possible extraterrestrial origin. This directional overlap is more than curious. It's statistically disturbing. Ninth, the impossible blue brightness. As Atlas approaches the Sun, it is growing brighter and turning a vivid blue, brighter and bluer than any known comet. This coloration is difficult to explain with known cometary materials or solar reflection patterns. It suggests the presence of exotic elements, unknown chemical processes, or even technological surfaces designed to interact with sunlight in unexpected ways. We are on the brink of what may be the most extraordinary chapter in the history of astronomy. An object named Atlas, initially classified as just another comet, has defied expectations at every turn. But what makes Atlas so unusual isn't just its behavior. It's the possibility that we may be witnessing something far more significant than a cosmic snowball tumbling through space. We may be staring directly at technology from another world. One of the most astonishing aspects of Atlas's behavior is how it seems to do the exact opposite of what any natural comet should. When a comet approaches the Sun, it typically heats up, causing ice and volatile gases to vaporize and create the signature tail that sweeps away from the Sun. This process also leads to outgassing, a natural ejection of material that can cause slight but measurable changes in the comet's trajectory, referred to as non-gravitational acceleration. But with Atlas, something deeply troubling and exciting is unfolding. As it nears our star, it isn't behaving as it should. It is accelerating, yes, but there's no visible evidence of the massive material loss that should accompany such propulsion. It's like watching an object get colder the closer it gets to a fire. This behavior is so counterintuitive, so contradictory to everything we know about cometary physics, that it raises only two possibilities. Either we are observing an as yet undiscovered natural phenomenon, or we are witnessing something technological. And that question, natural or artificial, now hangs in the balance as we approach the most critical observational window in the history of interstellar object studies. December 2025, the moment of truth. The coming weeks are not just important, they are historic. December 2025 marks the period in which Comet Atlas will pass closest to Earth, presenting a rare and fleeting opportunity for direct, high-resolution observation by the most powerful instruments humanity has ever built. From the Hubble Space Telescope and James Webb to dozens of ground-based observatories across 6 continents, the astronomical community will be watching. And they will be looking for one thing above all else: a gas cloud. Why? Because if Atlas is accelerating as data suggests, then, according to the laws of physics, it must be ejecting a massive quantity of material. The numbers are staggering. 5.5 billion tons of gas and dust should be trailing behind this object, spread across a visible plume that our instruments would easily detect. This isn't subtle. If it's there, it will be obvious. But if that gas cloud is not detected, if Atlas continues to accelerate without shedding mass, then something extraordinary must be at work. The absence of a gas cloud would rule out every known natural explanation. The only possibility that would remain consistent with the data? Controlled propulsion. Not random ejection from ice vaporizing, but intentional movement, possibly powered by mechanisms unknown to modern science. And that would mean one thing. We are not witnessing a comet. We are witnessing a machine, not an ancient artifact buried in Martian soil, not a fuzzy radio signal from decades ago, but active technology operating in real time within our solar system, under the direct observation of humanity. If confirmed, this would be the first definitive evidence of extraterrestrial technology. Not inferred through indirect signals or archaeological hypotheses, but witnessed live, with data streaming in from every corner of the planet. It would be, without exaggeration, the most significant discovery in the history of our species. The stakes have never been higher. This is not a theory born from imagination or science fiction. This is driven by pure physics. The laws of motion and thermodynamics are clear. To change an object's velocity without an external gravitational assist, energy must be applied. That energy must come from somewhere. For comets, it's from venting gas, mass loss creating thrust. But if there's no mass loss, then how is Atlas accelerating? There's no room here for vague speculation. The math doesn't lie. And the absence of that 5.5 billion tons of expected gas would be the smoking gun. Hundreds of telescopes will be scanning the skies, capturing every pixel of movement, every photon of light, every spectral signature that Atlas emits as it reaches its closest approach to Earth on December 19th, 2025. This date is not just marked on calendars, it's engraved in the minds of scientists across the globe. And the truth, it may change everything. What if it's not just a comet? Let's consider the possibilities. If Atlas turns out to be a comet unlike any we've seen, dry, metal-rich, impossibly aligned, showing technological optical polarization patterns, with a jet pointed toward the sun instead of away, then we must rewrite the book on cometary science. That alone would be a massive achievement, equivalent to discovering an entirely new category of interstellar object. But if Atlas doesn't behave like a comet in this crucial final test, if it accelerates without the expected plume, then we are no longer dealing with science as usual. We are standing at the threshold of something far greater. We could be looking at a probe or a drifting artifact, perhaps long dormant and now reactivated. It could be a beacon or a scientific instrument sent by a distant civilization eons ago, now gliding silently through our solar system. Or it could be something we have no framework for. Technology so advanced, so alien, that we struggle to categorize it with our primitive definitions. And here's what makes this all the more profound. This isn't happening in some unreachable corner of space. This isn't light years away. This is here, now, in our celestial backyard. And we are watching it, together, in real time. A moment for humanity. Think about that for a second. Imagine the timeline of human history, millions of years of evolution, thousands of years of recorded civilization, centuries of scientific advancement. And now, at this exact moment in time, we might be witnessing our first contact with evidence of alien engineering. It's no longer science fiction. It's science facing the unknown. And regardless of what we find, whether Atlas proves to be a technological marvel or simply the strangest natural object ever recorded, this moment will be remembered, because Atlas has already changed us. It has shattered our assumptions, pushed the boundaries of what we believe is possible, and forced us to ask questions we've never seriously asked before. We're no longer just observers of the universe. We're participants in its unfolding story. The countdown begins. So here we are, on the edge of revelation. December is almost upon us. The countdown has already begun. In just a few weeks, we will know. We will have answers. We will look up at the sky, not with blind wonder, but with informed awe. If the gas cloud appears, we may breathe a sigh of relief, knowing it was just a very, very strange comet. But if it doesn't, if the space behind Atlas remains silent and clean, then humanity will take its first step into a new era, one in which we are not alone, one in which the stars have spoken, not in mystery, but in motion. And in that moment, the universe will no longer be a distant dream. It will be a shared reality. So stay tuned, stay curious, because what we are about to witness might be the greatest discovery in the history of civilization. Either way, the skies will never look the same again.